quiz. Good old Cirky. Again, common strategies. Okay. If I can count it, I can solve it. I think there's some card questions where you're picking a single card later on, and usually I just count the number of outcomes in my head because I know what a deck of cards looks like. If I'm picking two things, usually my strategy is a tree. If there's two groups with some overlap and I'm only making one pick, I'll often go to a Venn diagram. So let's look at this. Number 1 says a bag contains 10 red, 6 green, 5 marbles. Determine the probabilities if 2 marbles are selected. You know what? 2 marbles are selected. I'm probably going to use a tree. The first one is that the first one drawn is white. Okay, let's see here. My tree I'm going to do over here, I'm going to have white, red, green. And since A just says the first one drawn is white, I'm pretty sure that is 5 out of 21. You know what? The probability that you get a white on the first draw, 5 out of 21. If I can count it, I can solve it. B. The second one drawn is white, given that the first one drawn is white and there is no replacement. I'm being cheap on this question, sneaky on this question, a little mean on this question, because it does say given, but this is not exactly a conditional in that you're not going backwards up the tree. Here's what it's saying. What are the odds that the second one is white if you know the first one is white? In other words, it's saying continue that branch. How many whites are left? Out of the probability of getting a white on the second, if I know that I got a white on the first, is just 4 out of 20. It's not didn't say and, it didn't say a white on the second and a white on the first. It just said, hey, if you know you got a white on the first, what are the odds of getting another white? 4 out of 20. Number 2, event A is defined as the chance that it will be sunny tomorrow. There's an 18% chance that it will be sunny tomorrow. What's probability of not A? 82%. Yes? By the way, in English, what would not A mean? So if A is it'll be sunny, what's the opposite of that? I think all we can say is cloudy. We can't quite say rainy because you can be cloudy and not rainy, but definitely I think we could say the opposite of sunny would be cloudy. The opposite of dry would be rainy, I think. Okay? Number 3. Did they give me percentages? Yeah. Did they give me 2 categories, hamburgers and pizza? Yeah. Did they give me a both overlap? A Venn diagram is my best choice. You can do this with the formulas. A Venn diagram is my best choice. It's going to look like this. Hamburger. This is not the question to do right before lunch. Pizza. There is some overlap, yes? What's the overlap? So what am I going to put in the little H circle? Not 60. What am I going to put in the H circle? 20. What am I going to put in the P section? 30. By the way, if this is a percentage, what do the percentages have to add to? How much do I have so far? And now I can answer the question. What percentage like neither? Hey, which is neither? The 20, the 40, the 30, or the 10? The 10. You can get this with the formulas. You know what? If you give me 2 different choices and there's an overlap and we're only doing one pick, I'll go with the Venn diagram. Number 4. I have no strategy to do this except to read. So I said, okay, a game begins with 2 cards being dealt. Gotcha. To win, the next card must be the same or be between them. If the first cards are a 3 and a 10, what's the probability of winning the games? I just started drawing a little picture here. I said, okay, I got a 3. I got a 10. What numbers are between those? So I said, okay, 4, 5, 6, 7, 8, 9. In a deck of cards, how many 9s are there in the deck? How many 8s? How many 7s? How many 6s? 4, 4, 4. Oh, but it also said not only could you win if you're between them, you could also win if you match them. How many 3s are there left in the deck? How many 10s? How many ways are there to win grand total? I think it's 1, 2, 3, 4, 5, 6 4s. 4 times 6 plus 3 times 2. You said 30? Out of, hey, how many ways are there to pick a card? The answer here is that. 30 out of 52, or in lowest terms, divide by 2, 15 out of 26. Let me think. I agree with you, Jordan. If the first 2 cards, you already know that a 3 and a 10 are sitting there, so you've moved down the tree a little bit. All right, there's only 50 left, which would be 15 out of 25. Oh, that actually reduces further. 3 out of 5, right? What's the probability of winning? Would you bet money to win this game? It's over 50%, then I'll always bet. I may still lose, but if I played this game 1,000 times in a row, the odds are very high that I'd come out well ahead. I mean, it's possible I could lose all 1,000 times. Not likely. And I think all those are 1 mark each, unless, 1 mark each. So kind of all or nothing, sorry. Says each of the 11 letters of the word mathematics are placed on a separate card. A card is drawn and not replaced. A second card is drawn. What's the probability that they're both vowels? And I said, hint, use a tree. How do I know to use a tree without the hint? How many cards are we choosing? Probably a tree. Okay. I guess it's going to be like this. Vowel, not vowel. Vowel, not vowel. Vowel, not vowel. Although, I'll be honest, Connor, because it wants both vowels, I guess I could have been really, really lazy, and I could have drawn my tree just only that. But I'll keep that there just... Hello. I'll keep that there just because. How many vowels are there at the beginning? 1, 2, 3, 4 out of 11. Change colors, Mr. Dueck, so it stands out a little bit. 4 out of 11. It says it wants both vowels, so let's just do this branch only. How many vowels are left? 3 out of. So it says, what's the probability that they're both vowels? It's saying, what's the probability of a vowel on the first and a vowel on the second? Did I say and? Yeah. What does and mean? It's going to be 4 out of 11 and 3 out of 10. It's going to be 12 over 110. Divide by 2, divide by 2. 6 out of 55? Whatever the heck that is a decimal, I don't care. Would you bet money on that game? Not a chance. Unless they were giving me a really good chance of, like, unless they were saying, oh, and we'll pay you back 1,000,000 times more if you win, then I might put down a couple of bucks, but I'm still almost certainly going to lose. Number 6. Sean, can you read to me number 6? Stop, that's enough. How many cards? Not a treat. I think I'm going to do this by counting and maybe some formulas. I don't know. Let's see. So the events are defined as follows. Event A, getting a heart. Event B, getting a face card. Event C, getting a 10. Oh, he brought me a note. A. I'm going to do this just by counting. How many hearts are there in the deck? 13 out of 52, which I think is 1/4. I don't care which answer you put. B. Getting a face card. How many face cards are there in the deck? 12 out of 52, which is 6 out of 26, which is 3 out of 13? No, that's wrong. 12 out of 52, what's that in lowest terms? Divide by 2, 6 out of 26. Divide by 2, 3 out of 13. I was right. Trust your brain once in a while, Dueck. 3 out of 12? 3 out of 13. C, getting a 10. How many 10s are there in the deck? Out of? I think 1 out of 13. Is that right? In lowest terms? And I've told you don't bother reducing to lowest terms. So if none of you have, good. I didn't bother. Not B. I'm not counting. I'm going to use the complement. It's got to be 40 out of 52 or 10 out of 13. Right? E, A or B. Here's what we said. Or means the first one plus the second one, but or doesn't just mean add. It means add minus the overlap. So it's going to be 13 out of 52 plus 12 out of 52 minus how many face cards are also hearts? 3 out of 52. It's going to be 13 plus 12, 25. Take away 3, 22 out of 52. Or 11 out of 26. By the way, I've argued for years that we should teach this unit in Math 8, because isn't this a better way to get good at fractions? Instead of just giving you a whole bunch of stupid fraction questions to do, actually giving you questions where the answers are fractions, but you kind of want to know how to add the answers together or multiply the answers together? I think, but I'm not in charge. A and C. What does and mean? Now, and means multiply, but there's an easier way to do it. And also means at the same time. We're only picking one card. Multiply would be if you're picking 2 cards. A, hearts. C, 10. Oh, how many hearts are also 10s? Sorry? How many hearts are also 10s? Or how many 10s are also hearts? Silke. Yeah, you know what? 1. This is really saying, what's the probability of getting the 10 of hearts? 1 out of 52. Ooh, gets a bit trickier. A or not B. So, hearts or not a face card. You know what? I'm going to use the formula. I'm going to go A, not B, minus, and the overlap. Let's see. A, I already said, was 13 out of 52, plus, we did not B, 40 out of 52, minus, okay, how many hearts are also at the same time not face cards? How many hearts are face cards? 3. So how many aren't face cards? 10. If I can count it, I can solve it. It's going to be 13 plus 40, take away 10. It's going to be 53, take away 10. 43 out of 52. H. Not A and at the same time not B. How many cards are not hearts and at the same time not face cards? First of all, how many cards are not hearts? 39. How many of those 39 are face cards? Christina. So how many aren't face cards of those 39? If 9 of them are face cards, how many aren't? You know what? I think the number of cards that are not hearts, 39, and at the same time not face cards, so remove 9, 30. 15 out of 26. I think that's what it reduces to. Okay. 1 mark for each of those. Just helping, I hope. Turn the page. I like number 6. I like number 6. I like number 6. Number 6 is a nice question. Okay. I'm going to give you a rolling 2 dice question on your test. I may do a 6-sided dice, or I may do a 4-sided dice. A 4-sided die is called a tetrahedral die. And for dice, here's the problem. If I gave you a 6-sided dice, 2 dice, you could do a tree, but you'd have 6 branches, each of which would have 6 branches. You have 36 branches grand total. It works, but we also said in our notes, sometimes a table works better. Same with this. What I'm going to do is a table, and my table is going to look as follows. It's going to be the first roll, 1, 2, 3, or 4. And on this column is going to be the second roll, 1, 2, 3, or 4. And my actual sample space then is going to be 1, 1, 2, 1, 3, 1, 4, 1, 1, 2, 2, 2, 3, 2, 4, 2, 1, 3, 2, 3, 3, 3, 4, 3, 1, 4, 2, 4, 3, 4, 4, 4. There, I've got every possibility. 16 outcomes. Is that okay, Rosanna? Okay. Now, I suspect some of you had trouble with number 6. Do you want me to pause for 30 seconds now that you have a sample space and see if you can quickly answer all the questions? It's not that, now it's just counting. So I'm going to pause for 30 seconds or so. So let's answer these. A says the probability that the sum of the 2 dice is equal to 16. Well, first of all, I can tell you it's going to be out of 16 because there's 16 possibilities. Sum of the 2 dice is equal to 6. You know what? 3 out of 16. Right? The product is a multiple of 3. Hey, that's also going to be out of 16. Multiple of 3 means 3 goes into it. You know what? That is that row there. Also that row there. That is 1, 2, 3, 4, 5, 6, 7. Don't count that guy twice. Right? 7? Yeah, but if you multiply those together, I guarantee if 3 was a factor, then the product has to be a multiple of 3. Yes? Is that okay? The number showing up on the first one is bigger than the number showing up on the second one. I'll do that in red. It's going to be out of 16. The number on the first is bigger than the one on the second. Oh, you know what? I think the first one, yeah, I think it's this whole upper corner, isn't it? That's where the first dice is bigger than the second? Right? 1, 2, 3, 4, 5, 6. The sum of the 2 dice is equal to 6, or the product of the 2 dice is a multiple of 3. Oh, you know what? They want to find where the or means add. You know what? Because I have it all circled. It's whatever's circled by blue or by black. And I'm just going to count them one at a time. It's also technically going to be 3 out of 16 plus 7 out of 16 minus the overlap. In fact, that might even be quicker. What's the overlap between the blue and the black? Just 1? So one way of doing this would be to go 3 out of 16 or 7 out of 16 minus the overlap. Or you could just count 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. out of 16. If you give me a sample space, whether it's a deck of cards, we did do some where we had the whole deck of cards printed up in front of us with little asterisks, or you know what, I'm going to give you a 2 dice question, and for dice, although it can be done with a tree, a sample space is your best bet, because then they can answer any question. 1 mark each. If each of the 15 outcomes in the sample space is equally likely, find probability of A. Okay. 6 out of 15, yes? Probability of B, 1, 2, 3, 4, 5 out of 15? Not A. 9 out of 15. I didn't actually count. I used the complement. Not B. 10 out of 15. A and B, the overlap, 2 out of 15. A or B. 1, 2, 3, 4, 5, 6, 7, 8, 9. By the way, or means add minus the overlap, so you also could have gone 6 plus 5 minus 2, which also gives you 9. But the reason that and equation works is because of that picture. Not A and B. Well, A and B was 2 out of 15. I guess not A and B is going to be 13 out of 15. Not A or B. Well, A or B was 9 out of 15, so what's not that? In fact, you know what? It's those 6 dots along the bottom row. Those are the not A or B. That's also neither. Okay. Number 8. Justin loves ballet. I did not know that. Cool. And Justin decides to enter 2 ballet contests. Now, you are versatile. I like that. He feels he has a 65% chance of winning the first contest, a 20% chance of winning the second contest, and only a 12% chance of winning neither. Using a Venn diagram, okay, let's set up a good Venn diagram. Justin, you sly dog. So there's contest 1. There's contest 2. Now, we did one like this in our notes. This is my way of checking who would go back and read their notes. We said for a Venn diagram, I'd like to find the overlap. I'd like to find and. In this situation, did they tell me the and? Did they tell me the overlap? Did they tell me the probability of him winning both? No. So we still want to start in the middle. So what I said to you is, put an X there. I don't know what it is. I'll replace it with an X temporarily. And then we slowly work our way out. What's the probability that he wins the first contest? 65%. Don't write this down. Am I going to put a 65 there? No. I'm going to put a 65 minus X there, because that's what I would have done if I knew what was in the middle. What's the probability he wins the second contest? Maybe it's a little higher caliber. Maybe it's a bit beyond his league. Only 20%, so 20 minus X is only winning the second contest, but not the first. Oh, and they did tell me neither was 12. Now, these are percentages. Here's the nice thing. Can you tell me what all these percentages have to add to? 100. In other words, this is how I can generate an equation. 65 minus X, that thing, combined or plus X, that thing, plus 20 minus X, that thing, plus 12, that has to all add up to 100. On the left side, I can gather like terms. 65 plus 20 plus 12 is 85. Am I doing this right? 85 plus 12, 97? Uh-oh, did I make up bad numbers? Sorry? It is 97? Did I make up bad numbers is what I'm wondering. I get 97, and then I get minus X plus X. Those guys cancel. Minus X equals 100. I made up bad numbers. I didn't crunch the numbers ahead of time. Dope! Oh, Mr. Dueck, you're going to have to omit this question. Pardon me? Well, no, it's negative 3%. Isn't it? When you solve this, you don't get 3. You get because it's 97 take away what equals 100. You get negative 3%. So I apologize. I made up bad numbers. Okay? If this had worked out, you would then stick this answer there and you could find the rest of the numbers and you could answer the questions. Winning both would be that there. Winning only the first but not the second would be whatever answer you got right there. Winning only the second but not the first, that would be whatever answer you got right there. Winning at least one contest, that would be that, or that, or that. But I guess I'm going to have to nuke those 1, 2, 3, 4 questions. So as it turns out, and I apologize, folks, this quiz is going to be out of 26, I think, if you carefully add them up.